All right, we're going to write an algorithm that's going to swap pairs in a linked list like this. So if we have 1, 2, 3, and 4, then we would want to have it return 2, 1, 4, 3. So we're swapping these two and we're swapping these two. All right, so to do this, we just need to use kind of a modified reverse where we're just reversing 2 at a time. So first, let's go ahead and make our node class. And it's going to contain, it doesn't really matter, say ints of data. And it's going to have a next. And if you're creating a new node, you're going to set data equal to D and next equals null. Okay, so there's our node class and our linked list would have a head in it. Okay, so what we are going to do here is create a function that's going to return a node, and it's going to take in a head. Okay, and we've got a previous that we need, a next, current, which we will start off as the head. And then we also need a counter just to help with our while loop. And so while count is less than 2, since we're just doing pairs, and current does not equal null, then we can go and say next equals current dot next. Current dot next equals previous. So on the first go around, previous is starting at null, so current dot next ends up being null. And then previous equals current, and current equals next. Then we just count plus plus, get out of our while loop. If next does not equal null, meaning there's still more elements in the list after we swap that first pair, then we're going to say head.next. This is going to assign the head that was sent into the function. Its next is going to equal, and we're going to recursively call this, and whatever it returns is going to be head.next. So then when we're completely done, previous is going to be what's still on head when we're done. So let's walk through this, see how it works. So if we have 1, 2, 3, 4, and 5. 5 is going to be pointing at null. 1 is our original head. All right, so we go in and we've got head, and then we've got previous equals null, or is pointing to null. And next is also pointing to null. And then current equals head, and count is 0. So we're going to want to keep track of count And we're also going to want, we'll make a little stack to keep track of our recursion. All right. So while count is less than 2 and count is starting at 0, and current does not equal null, and that is also the case, then next equals current.next. So now next is here. Current.next equals previous. So here we go. Current's next is going to be pointing to null, which is also what previous is pointing to. I'll make it a little bit more obvious. Okay. And then previous equals current. So now previous is here. Current equals next. So now current is here. And count plus plus. So now count is 1. Go around 1 is less than 2, and current is not null. So we go in next equals current.next. So next equals here. Current.next equals previous. So this is going to now be equal to this. And previous equals current. Okay, so this is now previous. And current equals next. So current equals next. And count plus plus, count's now 2, 2 is not less than 2, so we get out of the while loop, and then it says if next does not equal null, which is the case, then head.next, which it means here's our head right here, so its next is relying on what's returned when we call swap again. So this time when we call swap, and let's go ahead and say we're sending swap in at 3, and then, or let's actually label it like this. So this is our section that we're looking at from our first run. So we'll call that 1. So we keep track of that so that we can keep track of where we are. And then, all right, we're sending in now this number 3 node is what's being passed in as the head. So we'll go ahead and call it the head. And then previous equals null. So we kind of got our new previous equals null. And next is going to point at null. And current is head. And count is 0. So let me start that over. Okay, so while count is less than 2 and current does not equal null, which is the case, next equals current.next. So next is here. Current.next equals previous. So that is going to go here down to the null, that a little bit bigger. Previous equals current. Current equals next. Count plus plus, count's now 1. And next equals current.next. Current.next equals previous. Previous equals current. Current equals next. Count plus plus. Now counts 2. 2 is not less than 2. So we get out of our while loop. If next does not equal null, which is true, then head.next equals swap next. So this is our, we're going to label this section as number 2 in our recursion so that we know where we are. And then we know that we're sending in this number 5 node. So this is kind of our new head. and previous equals null, and next is going to point to null, and current equals head. Okay, and count is 0. Okay, so while count is less than 2 and current does not equal null. Okay, next equals current dot next. So next is here, pointing at the null for current, and then current dot next equals previous. So here's our current dot next. Previous is null, so it's already set to that, and then previous equals current. Current equals next. And count plus plus. Count 1 is less than 2, but current is equal to null. So we get out of that while loop. If next does not equal null, that is also not the case. Next is null. So then we just return previous. So we are returning the number 5 node. So from here, we're returning 5. So we go back to number 2, and that's this one here, and it looks like head.next. So this head, the next there, is going to equal the 5 that we just returned. So that's going to go to 5. It's no longer null. And then we get down here, return previous. So we're returning the 4, because that is the previous from this section. So we return the 4, and we go back here. Head.next is now pointing at the 4. Okay, and then return previous. And the previous in this one is the 2, and that is going to be our new head. So we'll be returning node 2. This isn't code. This is just me indicating that we are returning node number 2. So that's what we'll be returning with this previous statement, since that's the previous in this call. And it's also the last iteration of this recursion. So we are done and return the proper head. Let's write this out and make sure that it all lines up the way we think it's going to. So we think that it's going to be a 2, and that's the head. It's technically previous, but when we return it, it will be accepted as a head. And then 2 points to 1. Okay, 1 points to 4. And then 4 points to 3. I should say their next is, not points to, because they're not pointers. But then 3's next is 5. And then 5's next is null. All right, and let's see. We kind of look at that, and we started with 1, 2, 3, 4, 5, and we knew we wanted 2, 1, 4, 3, and 5. All right, and this is an O of n solution, because it goes through everything one time. Although it uses recursion, it's just assigning one thing when it's returning that element. So it's an O of n solution, and it is an O of n space. Well, it's probably more of an O of 1 space. So because behind the scenes, the recursion will use something like a stack, but that doesn't really count for calculating the space that we used.